that is in the liquid. That's called Henry's law. That the more pressure you have over the liquid, the more gas that will be in the liquid. Now, what happens when I open the cap, it releases the pressure, right? That's the noise that you hear. Well, when I seal it back up and I let it sit for a while, what happens? It builds up pressure again, right, as the gas leaves the liquid, and then I release the pressure. Every time I open it, I'm making the pressure go down, so it loses gas. So what's the idea? How do you keep your drink from going flat, as we call it? Sealing it up and never opening it. Or you open it and drink it the first time, right? Or alternatively, if you seal it and you want it cold as well, right? Because cold helps the solubility of gases. Here's the other thing. If you buy 2-liter drinks, I don't buy 2-liter drinks, but if you do, when you open them and you're going to store it instead of sitting it on the counter, take it and squeeze all the gas out of the top, seal it up, put it in the fridge. That'll make it last longer. Because that way the gas doesn't have any place to go, right? It's sealed up. The bigger the headspace on it, the bigger the area, the more gas it will leave the liquid and go into the gas on top. Okay? Does that make sense? So when I ask you on the test, how do you make your drink last longer? What do you say? Squeeze the bottle, get the gas out, seal it up tight, store it in the fridge. Or drink it the first time you open it. Why are you bothering to store it, right? I mean, come on. I don't do that. So, all right. So let's move on. The next section in your book talks about solubility of different salts. We're not going to cover this, okay? I'm not worried about it. I don't think it's important for you guys. Not all, we said most ionic compounds are soluble, but not all of them are. There are lots of exceptions and stuff, so we're not going to worry about all these rules for solubility and stuff. With one big exception, here's something that you guys may eventually see. I know some of you want to be nurses or vet techs or something. This is a common technique that they use. They make you drink a barium sulfate solution. And barium sulfate in your stomach is not soluble. And then they take a radiograph. So it goes from being soluble to being insoluble, so it precipitates. And it coats the inside of your colon here. Ew. Because you basically have little particles in there, right? So when the x-ray hits it, it's like having little rocks in your stomach, basically. They're just little teeny tiny ones, you can't see them, right? They're just coating the entire GI tract. They're looking for holes and stuff in your tract. And yeah, it does look like a parasite, doesn't it? Kind of gross. Yep. And here's some other salts that are not soluble, right? Cadmium sulfide, iron sulfide, lead iodide, nickel hydroxide are all examples of ionic compounds that are not soluble. There are quite a few of them. We're not going to worry about these. Because what we want to spend our time on today is concentrations and dilutions. Okay? Concentration of a solution. Concentration of a solution is our way to say how much solute you have in a given volume. Okay? It is always solute divided by solution. So, and we're going to show different ways you can express this. Okay? In this case, they're making a solution. They're adding 5 grams of potassium iodide to a 1 liter solution to make a solution. So, 4 different ways to express concentration units. Okay? Mass percent, volume percent, mass volume percent, and molarity. Okay. These 3 percentage units or different ways of expressing it are all used very similar. Note up here, it is always the amount of solute divided by the amount of solution. We're going to go through each one of these one at a time, okay? I promise. We're going to spend a lot of time on molarity. So, mass percent. Mass of solute divided by mass of solution. Not mass of solvent, but mass of solution. Volume percent. Volume of solute divided by volume of solution. Mass volume, mass of solute, volume of solution. Molarity, moles of solute, volume of solution. Note on the bottom, it's always solution, and on top is always solute. So, here's mass percent. It says, it's the concentration in grams of solute divided by grams of solution. So note, you have to add solute and solvent together and then multiply the whole thing by 100. And that'll give you a percentage, okay? If you're given the mass percent, so let's say that you're giving a solution that is 5% mass. Wow. 5% mass. That means it is 5 grams of solute for every 100 grams of solution. Okay? So that's what the percentage means. It's always solution on bottom and solute on top, even if we change these percentage units. So, can you calculate what percent? It says when water is added to 8 grams of potassium chloride to form 50 grams of potassium iodide. So potassium chloride solution, the mass percent is 16%. Why is that? Well, let's look and see. We have 8.00 grams of potassium chloride divided by how much solution do we have? We have 50 grams of solution, right? That's what it tells us. How much solvent do we have here? How much solvent is present here? If there's 50 grams of solution and 8 grams of it is solute, how much is solvent? 42, right? 50 minus 8 is 42. We can all do that in our head, right? We're good? Times 100, that equals 16.0%. And you always have to put this right here, because it might be mass volume or it might be volume. Okay? The difference between mass and volume is density, right? We're not going to get into converting them, but you could. Yes, ma'am?
Can you go back so I can finish reading the equation?
What equation?
The one before, like, the mass percent.
Mass percent is grams of solute divided by grams of solution times 100. Okay? Does everybody see how I got 16% here? We're all good? Okay. So, and they're just doing the same calculation. Now, we can use that to calculate things. So, can you calculate the mass percent for this solution? Let's work on this for a minute. Not too long. It shouldn't take you long to do this. Are we ready? Y'all write all this problem down. Y'all know these slides are on mastering, right?
Yeah.
If you go to the study area, you can see the slides. Yeah, but if you spend all day writing a problem down, you never get to work on the problem.